Okay, here's our second example. Let's list out our knowns. We have initial concentration of A. Initial is 1.24 molar. The time is 310 seconds. It's in seconds. And so is the unit that we have for time in K. So there's no need to convert to minutes or to hours. So K is given this time. It's 0.0234 units of K for a second order reaction, or molar to the minus 1 seconds to the minus 1. Okay, so now we want to solve for this. We want to know what the concentration of this reactant is after 310 seconds at a certain temperature. Okay, so we're just going to plug it into the integrated rate law. And I'm going to do this one quickly this time. So this is going to be 1 over, and our reactant is sulfur trioxide, so SO3, minus the initial concentration, which is given as 1.24 molar. Okay, we're not going to square this. We're not using the rate law, we're using the integrated rate law. Okay, so 1.24 molar, and that's going to be equal to K, which was given as 0.0234 units, molar to the minus 1 times seconds to the minus 1, times time, and time was 310 seconds. The units of second cancels, and we end up with here 7.254, and we have 1 over the concentration of this, whatever it is, minus 1 over 1.24 molar. Next step is to bring this to this side, is equal to 7.254 plus 1 over 1.24 molar. So 1 over 1.24 is 0.0865, or 0.8065, excuse me. And I'm going to round it out a little bit further, so 0.80645. And so now we can add those two together. 7.254. And I get 8.0605. So our last step here is to invert both sides. Just flip them, and I explained this in the previous example if you want to see more detail. But we end up with the concentration of sulfur trioxide at 310 seconds is equal to 1 over 8.0605. Okay, so 1, and that's m minus 1. Excuse me, I carry my unit that I have here. 1 over that is equal to 0.12 to 2 significant digits, yes, molar. So our unit's there. So when I divide by a fraction, it flips and I end up with molar. So my answer is 0.12 molar.